present. Levin and Martin talking about WebRTC.
So, good morning, everyone. Indeed, today we want to present WebRTC. Myself, I'm Desmet. I'm a research manager at the KU Leuven on application security. I'm actively engaged in OWASP, so I'm also one of the local organizers of this conference. So I'm really hoping you have a good time here. And I'm also the program director of SecEU.
Yeah, hi, I'm Martin Johns. Actually, I don't work at SAP AG. I noticed I work now at SAP SE, whatever the difference is there. Same company, new name. And there I'm responsible for leading all the research activities. Application security. I do some OWASP stuff involved in OWASP, I think, since 2006, now with the German chapter. And I occasionally speak at nice places, nice conferences about nice research. So Levin and I were doing, since 2 years now, a research project called Struce, which is doing, exploring the security boundaries on future web technologies together with the ITF and the W3C. And part of the results of this project we will present now in respect to WebRTC.
So, for the talk today, what we want to start with is actually giving you an overview of WebRTC in a nutshell. So WebRTC is actually a combination of a lot of technologies, both on the networking layer and within your browser. And we will give you enough details so that you understand the security and privacy assessment report that we will do today. So one of the things that we will zoom into are the communication protocols, so actually at the network layer. Then Martin is taking over and we'll talk a little bit more on the developer view of WebRTC. How does it look in the browser? What are the APIs that you can use? And then we zoom into the privacy and security assessment itself. So Martin, maybe you can first introduce WebRTC.
So okay, what is WebRTC? WebRTC is, on a very basic level, the capability for you to develop stuff like that in your browser. So it's native browser capabilities to build something like Lync, like Skype, like Adobe Connect in the browser. And this is done by enhancing the browser with native capabilities for peer-to-peer data streaming, and we go deeper into what we mean with peer-to-peer in this respect. And they are fully driven by powerful JavaScript. So there's a lot of flexibility, but I think it's easier. I think we have somebody else that can explain it much better than I can. So do we have sound?
Yeah. Mark Simpson over at Mozilla. I'm going to show you the latest developments in WebRTC. Here you can see I'm just going to a web page that supports WebRTC. Firefox asked me for permission to use the camera and microphone, which I give it, and make it a call over to our friends at Google.
Hey Todd, how are you?
I'm great, Hugh. How about yourself?
So apparently it's very great. So this should give you, if you feel how it feels in the browser to use WebRTC. So we will develop we will show you the architecture of WebRTC, which is not trivial. Hence, we will build this slowly. So we start with the simple case. So you have browser A and browser B, and they want to do this peer-to-peer video and audio telephony that you just saw in the video. But before they can do this, they need to be connected to each other. And the way they are connected is done via the so-called signaling channel. So this is the term that we will use through the talk. So the signaling channel is the connection between the two browsers. And the signaling channel is set up in a classical web application way. So you still need something like a web server or something else that is able to talk to both browsers so that it can exchange the basic parameters and actually make both browsers aware that a peer-to-peer connection is supposed to happen. As soon as all those metadata has been exchanged via, for example, disconnecting web server and HTTPS, a peer-to-peer data channel, the media channel usually we call it, is set up using a non-HTTP protocol based on DTLS and HRTP. We'll talk about this later on. And now all the actual media streaming, so the data streaming, the streaming of the video and the streaming of the audio, is done between the browsers and not passing through any web servers. So I already mentioned or hinted that one of the design philosophies of WebRTC is flexibility. This means you're not confined to this rather simple scenario. So you can deploy, WebRTC in a multitude of ways. So in the very, very even simpler case, you can just set up a data streaming connection between a web server or just a server internet and the browser. then you can do this thing that we just introduced, where you have one web server connecting two browsers, and then they do peer-to-peer streaming. But as this signaling path here is done in pure JavaScript, you can let loose then, you can do whatever you would like. And a very common scenario that we expect to happen is that you actually have two signaling servers. So browser 1 uses application A for its WebRTC communication. Browser B uses application B. And application A and application B, somewhere behind the curtain, do some connection, handshake, exchange of the information to connect the two browsers. So in this case, in layman's term, you then can call from Google Talk to Facebook, something like that. And also with WebRTC, as you have the flexibility of the signaling channel, you also can connect your browser now to legacy or already existing communication infrastructure, something like XMPP or SIP, anything. Also, you're not confined to pure peer-to-peer communication as we see here. And so you can have your media channels also set up in a mesh network, so you can have like video conferencing where each browser is connected to each other browser. You can have a star network where one of the browsers forwards the streams of the other browsers over the network. So you can have something like a decentralized but still conference calling. And you can use dedicated boxes that do the multiplexing that's there, of the streaming data, and also doing some fancy post and pre-processing. Especially there, we will see quite a bit of innovation in the so-called marketplace.
So,
good.
So good. Now we actually saw, very basically, we have the signaling part, we have the media part. Now we'll zoom a little bit more into detail, how they actually are being set up, what is actually technologies being used, so that we can also use that insight in the security and privacy assessment. So as already mentioned, the signaling part, it's just actually to exchange data between the endpoints. So you're actually exchanging control messages and metadata about your P2P connection. This is a very classical way where you set it up to a central server. So this is really a centralized paradigm. And what's important in WebRTC is that this part of the technology is not specified. It means you need, of course, the metadata, what you need on the client sides, on the endpoints is specified, but it doesn't say any specification on how you actually exchange that data to the other side. So you can actually use, for instance, Socket.io, which is actually what we did in some of the coding fragments that are coming later. You could use XHR. You could even use any protocol you want to exchange that data between the two endpoints. For the media part, it's much more standardized. So the idea of the media part is that you set up a secure connection between the two endpoints, or multiple endpoints, as we saw in the previous topologies. You're using that to actually exchange streams, so video streams, audio streams. You can have multiple streams over the same peer-to-peer connection, but you can also have a data channel to exchange control messages or even to exchange data. For instance, think about the video conferencing where you have like a chat box underneath. That data can go over a data channel. And it's all part of the same technology that we're presenting here. What are the technologies or the protocols being used to make that connection? DTLS is the basic technology. It's a datagram style protocol using features from TLS integrated in the datagram. So it's actually HTTPS, but then with UDP. And you're using SRTP on top of that to actually having the streaming protocol in a secure way between the two endpoints. The features of those protocols is they're providing encryption, message authentication, and integrity. So how do we set up the media part? So how do we actually get that peer-to-peer connection? There are two phases. The first phase is you exchange the media parameters. So you're actually exchanging the metadata between the endpoints so that they can know that they have compatible video, for instance, to be exchanged. Coding information, also information about the endpoint and so on. And that's all captured in the session description protocol. Once you know that the two endpoints can communicate, the next step is actually exchanging all the network parameters to get that peer connection ongoing. And they're using actually a whole set of technologies, and all those technologies are actually borrowed from SIP, so they're not new for WebRTC. They're actually reused components that already exist in that infrastructure into WebRTC infrastructure. I think the most basic one is the UDP pinch holing to actually setting up the connection between the endpoints. I will zoom in a little bit later. So first, the metadata. I mentioned session description protocol. How does it work? You have actually your browser A and browser B. They're using the signaling part to send over what are their capabilities, what are the supported codecs, what multimedia types, what are the devices that are actually at each of the endpoints. And they're sending offers to each other and an answer, and based on that they actually can make the calculation, this is a match for the two endpoints to communicate. We don't go in a lot of detail in this presentation on SDP. I'm just showing you a screenshot of what actually is in an earlier draft of IETF of such an example of an SDP. So it's a lot of technical content that you already need. This is actually just taking over from the SIP infrastructures. What's important is this is actually represented as a string within WebRTC. And since you actually in JavaScript are passing along that string, you can manipulate that string. So for now, you could easily say, well, I'm passing that to the other side to actually setting up our connection. But in the future, you could have libraries that are actually having additional filters or changing the information on the SDP. And we'll see that later on is important in our assessment. The second part is how do you do the networking stuff? The basic idea is you have P2P connection. But as we all know, most of the people are actually now using NATs, firewalls in between. So it is actually not so easy to reach directly from A to B. We don't have public IP addresses on most machines. So we're using well-known technology, UDP punch holding, where, for instance, we are connecting to an external public service. The NAT is opening an incoming connection on the firewall to our browser. The other side does the same. And in the most optimal case, that's sufficient to actually get a P2P connection even over two different NATs. How do we use these technologies within WebRTC? Well, actually, we're using services to help us with the whole hole punching and to retrieving the necessary information. So that's where stun, turn, and ice come into the picture. We don't discuss it into detail, otherwise we need actually the whole day to explain WebRTC. What we see is stun. Just remember, stun is actually getting all the information you need about your local machine. You need your local IP address, the subnets, NATs. You actually get all the information on your side of the network. And actually, you're using that one to let the browser decide how you connect to the other side and vice versa. The turn service is actually in case where the hole punching, where I just described very visually, doesn't work. Turn is actually a service where you can say, I can't directly connect to Martin, for instance. I'll be using a third-party relay to actually relay our stream over that third party. At that moment, the turn server is actually handling as a kind of an intermediate service, passing on the packages between our two endpoints. And ICE, I also mentioned that term, is actually bundling all that information about stun and turn before it's actually being exchanged between the two endpoints. So again, think like SDP. It's a kind of a string representation of all the information about stun and turn. All the things that you actually retrieved from those services to exchange. So the image that we had before on the architecture is now getting a little bit more complicated. We're actually saying, well, also in order to set up the dark green line with DTLS and SRTP, we need to involve stun and turn to actually get all the parameters to be able to set up the architecture. But of course, you see, we have still some white space on the slide. There's one more thing in the whole WebRTC thing, namely identity provision. Identity provision is put into WebRTC to help WebRTC to be able to identify what is the endpoint I'm communicating to. So I'm connecting, for instance, to Martin. How do I know that actually I'm connecting to Martin? And there we're actually introducing proxies to known identity providers. So every identity provider could actually pick up a service that then can connect to WebRTC, and WebRTC can use it. In practice, how did they do that loose coupling within WebRTC? So this is actually based on the specs. You're loading the identity provider into an iframe in its own origin. Then you're asking with post messages to the identity provider, give me an identity assertion so that I can pass along to the other party that I'm, for instance, leaving at Google. That one gets passed to the other side, to the browser via the signaling path. And now the browser B can say, ask to the identity provider, can you really assert that this assertion is correct? Is this really the identity at the other side? And if you're putting that all together into the previous picture, then we can actually get an authenticated endpoint in our DTLS communication. So the architecture becomes a little bit more complex. We're also using the identity provider to get assertions, and we're using also the identity provider to verify assertions. And just like with the signaling server, it's also possible to have different identity providers for each of the endpoints. So with this, we actually are discussing the communication protocols underneath. This is something that, for most part, actually will be hidden within your WebRTC view as a developer. But now we actually go to see what does the developer see. Martin?
Thank you. Also take this picture in mind and then think about the deployment slides that I showed you when you have multiple browsers and multiple servers, and then it gets arbitrarily complex if you want to take it that way. So let's, because we all, or most of us, deal with JavaScript, I guess, in this audience. So I think it's always interesting to see a little bit under the hood. So how do we deal this on a code level with it? And what do we have to do, and what is given to us? And so WebRTC in the browser is pretty much a set of magic capabilities that come out of the new browser capabilities with JavaScript APIs, and a lot of handiwork that have to do to set up the connections. So what is given to you, so the JavaScript APIs have three main purposes. So one, obviously, they need to handle the streaming of the data. So they need to be able to get your local data, your local streams, your local video, your local audio, to be sent to the remote party. And also they need to be able to retrieve the remote audio, video, and data to be handed back to your browser, to your DOM, so that you can actually display this. Then you need capabilities to set up the peer-to-peer connection. So somehow the JavaScript has to let the browser know, I would like to set up a peer-to-peer connection. And then there need to be methods from the, so that we can retrieve all the metadata from the underpinnings, so getting all the STP and ICE information that we even introduced to be passed on to the signaling channel. Because remember, the signaling channel is something that we have to develop ourselves, that is not given to us. So we have 3 slides and simply showing you some JavaScript code. So setting up an RTC peer connection is simply pretty easy. So you need some configurations. You have to let more or less the browser know which external servers you would like to use for setting up the peer-to-peer connection, more or less how you would like to do the UDP hole punching. And then you just instantiate new globally available JavaScript objects, and with the instantiation and giving the configuration, pretty much all the hard work is done. And then you only have to exchange all the separate information. So we go here now. So again, we have our browser A or our browser B, and the web server in the middle that is used for setting up the signaling. And so the color code here is everything is red is built in the browser. This is native APIs provided by the WebRTC capabilities. Everything in purple is stuff that you have to do yourself. So the signaling channel is up to you how it's implemented. We used Socket.io, but you could use XHR. You could use email if you would like to. Everything works. And so more or less, after instantiating your global WebRTC peer connection object, you ask it for, please create an offer for me. So then the JavaScript queries the browser implementation on all the metadata that is needed for setting up the connection, puts it in a big string. We put the big string into a big JSON, and we send the big JSON via HTTPS to the web server, and the web server is responsible for sending it further onto browser B. Now browser B receives this offer, takes this JSON and puts this into its own peer connection object. There it's processed and based on the information of the SDP offer, it creates an SDP answer, and this has to be sent back over the signaling channel to browser A and browser B. And if this has happened, then over our application-specific signaling, and if this happened, now both browsers are aware, okay, a peer-to-peer connection is supposed to happen, and these are most of the necessary information that I need. So the stuff that is still missing is, so this is the information that the connection is supposed to happen. Now we need the information how this connection is supposed to be happening, and therefore we need the ICE candidates. So it's pretty much the same process. So browser A queries again the capabilities, please give me the network parameters. We get them, we send them over our custom signaling channel to browser B. Browser B receives them and inserts them in the peer connection, and browser B does the same. This could happen in parallel. And then also we have exchanged information how to connect. And now we have a working peer-to-peer connection between the two browsers. As a final step now, the JavaScript tries to get access to the local medium. And so in this case, we would like to have the audio and the video of the local computer. This triggers now a confirmation dialog. Would you like to share your video, your camera with the web page? And if you say yes, I would like to, then a JavaScript stream object is generated and passed on to our JavaScript, and we, as a developer, take the stream object and feed it into the peer connection. And this automatically sends or communicates this stream that we have here directly over our media channel or the DTLS channel to the browser B without the web server in the middle. Okay, so this would be now a good time, I guess. And we have the time. If there are any technical questions on the setup, maybe you want to pause them now because this we will need for the security stuff.
actually, we're having a slide at the end of the talk about the identity provider, but indeed it's underspecified. At this moment, everyone can be hosting the identity provider. The idea is the string is the domain where the identity provider will be running, where every party could actually play the role as an identity provider within the specs. Let's come back to that when we actually are showing the identity provider in a little bit more detail in the attack scenarios. But indeed, at this moment, I think it's actually closely related to either browser or the signaling server, because you actually want to know, I want to set up this connection. You either already have an identity and the signaling server is supporting that, or you actually say, well, the browser might help me out in actually identifying which identity providers I can use. But I will go on that a little bit more detail later. But I think it's a good question. So also you saw quite some fragments now of code in the WebRTC. I don't think it's important to read them all. I think what's a meta message on this code fragments, if you're actually coding a very simple video end-to-end streaming, like we saw for instance in the video, I think with like 50 lines of client-side code, 50 lines of server-side code, you have this all up and running. You have and some of the infrastructure components that you can already reuse from SIP. Everything is very well shielded from the user within the browser, so you can actually very easily integrate this within your application. I think this is also one of the advantages of this technology. But of course, we would not be here if we're only talking about the advantages and how cool the technology is. We also did a security and privacy assessment of the technology, and we will show you some of the highlights that we found during the assessment. And afterwards, we'll come back on actually some take-home messages. The first one, and it's of course also the most obvious one, we're introducing a lot of new technologies and protocols. Our attack surface has changed. And I try to visualize this. So I think for this talk, we're mainly concerned about the attack surface that has increased between A and B. Now all of a sudden, for instance with the data channel, there could be data coming in directly from a browser, not from the server. Think about the problems that we had so many years ago when the first DOM XS was introduced. We always thought the server is actually responsible for cleaning up the code before it's going to the client. Now all of a sudden, some of the client code was getting executed. Now again, we could get input coming from B to A, and we need to make sure that we sanitize it before we're using it in our functionality on the client side, because we might not trust the other browser endpoint. So that I think the attack surface that increased is important. And it's even more important to mention. It's of course in the case of WebRTC, but also take this into account. If your technology is not using WebRTC, your application doesn't use WebRTC yet, then make sure that you also think about this input, because any attacker that is introducing cross-site scripting, for instance, if you went to the HackPath talk, you saw a lot of ways to get actually code into the client side. Well, every of those attackers can also use this channel to feed additional data into your browser. And I think this is also something important, because we typically take into account that everything is going over the HTTP channel and we can actually view it. And this is something to take into account. I think the second thing I want to discuss is the permission model of WebRTC, and also how the user is actually involved in giving consent or is aware of the fact that certain permissions are actually given to the code. And for this, I would like to do some kind of a small quiz or some. I think it's good to think about the permission model. And what I would like to do is, for each of the things that WebRTC is doing, just wave your hand if you would like to be informed of give consent for that feature to happen in your browser. And I give a very simple example, the first one. If someone is actually using your camera to stream you, would you like to be involved? Yeah, of course, everyone wants to be involved. Well, the good news is you are involved. You already saw within the previous slide of Martin, you actually see the pop-up, do you want to allow the camera and video to be given to, the camera and the microphone to be given to the client? Yeah, the microphone, yeah. Who wants to be involved for the microphone, for the quiz? Yeah, everyone is there as well. Is there do it in reverse. Who doesn't want to be involved? Nobody, of course. Okay, 13. Before ICE is actually fetching all the data about your local networks, net information, subnets, and so on, do you want to be involved or know that? Bad news, you don't, or you're not involved. And we already saw attacks in the last year of actually people using this information to fingerprint you or do the reconnaissance on the client-side network. Because you can easily, with new APIs being added to the browser, just ask what's the local IP addresses, how does the internet look like in that company. If you're setting up a peer-to-peer connection, do you want to be informed of give consent that you're actually setting a peer-to-peer connection directly to another browser, even behind nets? I would say half of the audience. Unfortunately, you're not involved in any way. So all the peer connections have been completely transparent. Until now, the only thing it asks is, do you want to share your camera and video over that stream? If you're only sending data, you're not involved at all. So, like I mentioned before with increased attack surface, if they're just setting up a data channel without a stream, they can pass on data without being you informed. Sending your video to a remote peer. Do you want to be involved? Yes. So I will clarify a little bit. So in case you already gave your microphone and video to the local application somewhere in time, and for some permissions, it can take long in some browsers to remember that permission. The fact that now your video is suddenly connected to a stream and is pushed away, you're not informed, you're not actually asked for consent in the browser at this moment. Sharing your screen. More people than with the previous one. This one is a little bit more ambiguous. So I'll have to state that correctly. So in the WebRTC specs, it's not allowed for a website to ask to share your screen. So by default, it's not an API that is available to the website. What they propose as solution is that it's available to the extension line. So if extensions ask for that permission, they could actually get the permission to share your screen. And in this sense, it's a little bit ambiguous because the trust model is you trust the extension to be installed in your browser, so you already gave the permission, but it's a little bit up to the extension how to notify you that it's actually using that permission on which sites. So in that sense, I think it really depends on the quality of the extension whether you will be informed about sharing your screen. Selecting an identity provider, this was also one of the questions, how do you interact with identity provider? Do you want to actually be informed when you're using an identity provider or you're loading an iframe, for instance, from Facebook or Google? It's just an iframe, you can load it. It depends on the identity provider, well, it will automatically give the assertion yes or no. So it could be, for instance, if you're logged into Facebook, that the identity provider Facebook just says, we're using the cookie to say this is real identity. At this moment, it's unspecified because the identity providers are not practically in use yet. And last one. So we have the whole idea that we are authenticating the endpoints. Do you want to have any consent if you're setting up a connection, who you're connecting to, or if the connection is established, who the endpoint is? Unfortunately, also the specs there don't say anything what they need to visualize to you. So they don't say that they, for instance, would need to ask permission to connect to Martin, or if you're connected to Martin, that you say, I'm only connected to Martin and not to someone else. So I think for the permission model and the consent, at this moment, we have more, the functionality is there. I think we need an iteration to think about what is really needed from the user. And it might not be that we need to pop up like 20 permission dialogues. Do you want this permission or this permission? Because it's very hard for users to differentiate. But I think certainly for the more tech people like you're in the audience, the fact that you can actually identify that the connection is being set up and to who that connection is being set up, the visual indicators are really helpful in this part. And currently they're lacking and they're also not specified. Good. Next part. We're now looking more on the privacy side. We did an investigation where potential data could leak. Because now we're setting up certainly a P2P connection. And in our first beliefs, we say, well, we have a P2P connection. We're a little bit under the radar. We actually have communication that nobody's actually tracking. And we actually went to the architecture again and tried to identify which parts in the architecture can actually see that communication is happening between A and B. And for instance, the most obvious one is, of course, the signaling part. The signaling server is sending around the metadata, even with identities, fingerprints, all that information along between browser A and B. So, of course, the signaling server is aware that communication between A and B is happening because all the control messages are sent via that path. Also, important, if you're actually collecting information via stun, you're actually information, I want to set up a connection. At this moment, we expect that only a few large providers will provide the stun services. And so people that are now experimenting with WebRTC are typically using, for instance, the stun of Google to connect. So at that moment, a lot of data is coming in at Google as well, and they could do some aggregation to see which connections have been set up at that moment. More important, if you're using the turn to relay, of course, the turn has a very good view of which connections have been set up between two parties. So third, less obvious maybe, any JavaScript you're loading in the domain of the domain that is actually using WebRTC can actually have JavaScript hooks into your page that is actually being notified for all the communication that you're doing from the domain. It can be malicious, like across a scripting attack that actually has this feature, but you could also imagine that larger companies that has, for instance, analytics on your page, have the capability to also see what are the remote parties that you're communicating from that domain. So also there, be aware, the JavaScript that is running in your application actually has the same power as the signaling server. And fourth, since you're using an identity provider in some cases, when you're using an identity provider to create the assertions and to verify, the identity provider knows pretty well that you actually have communication between the two parties. So it's peer-to-peer, but think about NSA. They might have ways to actually know that you're communicating with the other party.
So speaking about privacy implications, another thing is that local network information is now, for the first time, legally available in the JavaScript space. So look, who's running JavaScript in your browser? Pretty much every single page that you're accessing. In our picture, it's the third-party JavaScript in the web server. But for the stuff that I would like to talk about now, it doesn't really matter, because we saw before in the permission model that pretty much everything besides querying your camera and querying your audio is done transparently without your knowledge or consent. So all the APIs can be done also by this one shady web page with the funny cat video that you would like to look at. And so this page can also then instantiate RTC web connection. And now the ICE, all the SDB parameters, as you see on the JavaScript thing, and also all the ICE information are available by creating offers and by asking the WebRTC connection to do an ICE candidate. And so this is a very simple ICE candidate, and it's very interesting. So some of you already might know this because it was in the media. There's some interesting information here, because for doing UDP hole punching, the external party need information about the local setup. So this is your local IP address. And so we have now a JavaScript API that can be instantiated by every single web page that you visit to obtain the local IP address and then send it away to everybody that they would like to know. And so this is a screenshot. The interesting part here is this is in the incognito modus. But still, this reliably gives you your local IP information. It doesn't even matter if you're using Tor or anything else for anonymized browsing, because this meta information is so essential for setting up the peer-to-peer connection. There's no way of hiding it as soon as you have the WebRTC in your browser. And I remember back when we were first exploring the field of doing network-based attacks with the browser, we had to jump through a lot of hoops to get the first impression of what your actual IP address is. We had to instantiate Java applets or do some strange FTP connections. Now, it's rather conveniently built into the browser, so it's quite a problem.
I see the beef guy already smiling. Just shut up. So the next thing, we already know that meta information and maybe IP addresses are leaking. What I'm also very interested in is, what about the confidentiality? So I'm exchanging data with Martin. Is that someone able to eavesdrop on the connection? So we actually worried, is it possible for a network attacker, for instance, to actually come into between browser A and browser B? And the good news is, we're using the DTLS and SRTP protocols, and they provide the encryption, message authentication, and integrity. What it does is actually, you have a certificate in your browser to be used to do your communication over your peer-to-peer connection, and the fingerprint of that is being sent to the other side via the signaling server. So you actually think about, Jim's talk about the non-traffic between A and B, and you're doing certificate pinning. Well, actually, your fingerprint is also part of that certificate pinning for SDP. So that actually makes that the network attacker has a hard job in actually seeing your network traffic. But of course, this is only the network attacker. We're going a little bit further, because all the information is being sent over the signaling path. We actually are interested in who actually can see also the information from the signaling side and is able to do a man in the middle. So I give a little bit more insights in how actually everything is put together and sent to the other side, and then we will see what are the potential attacks in this. So the first thing is you're collecting all the information on network paste. You're collecting all the information from the keystone, like your certificate you will use, the fingerprint, and so on. You're combining that all together in your SDP, and then within your SDP, you're sending that to the other side. So nothing bad happens. But what if one of the components, being it the signaling server, being it the third-party JavaScript, is actually able to modify SDP? And as I said before, you're easily able to modify because it's just a string representation of the SDP. At that moment, you could say, well, you don't have to connect to this IP address, or you have to connect to another IP address with another fingerprint. And from that moment on, your browser will actually do a man in the middle, connect to a man in the middle. Because your new modified SDP is referring to this man in the middle. And this picture, you always have to think it happens in both directions, so you need to adapt it in both directions to make sure that both of the browsers connect correctly. So this is a little bit pity, because this was actually what the whole the DTLS SRTP wanted to protect to. Because now, it will easily connect there. So this is one thing, and we will discuss in the next slides how we can actually tackle that. I would also like to mention that this is not the only attack. So this was the attack, the man in the middle, as we saw just before. There's actually another attack also that Martin became aware while doing the research. It's very, very easy if you have the JavaScript APIs here. When you're actually using the stream of your endpoint, you could reroute your camera to an OTP connection as well. So if you have malicious JavaScript of your signaling server you can't trust, once you set up your video to communicate to party A, it's only 2 lines of code to also pass that video to party C. Or even to receive the video from Martin and send it along to another party. Yeah. Yes, a browser extension would be able to do that from the browser extension, and if not, it can easily inject the content into the page to do the same for him. That's easily possible. And at this moment, since we don't have any identifier where your stream is being pushed to, you don't know that data is rerouted or not. So I promised to go back to the scenario with the man in the middle, because the other thing we don't have a good solution that we can present today. For the man in the middle, we have a better solution. So we actually, I said I had one more thing that I want to introduce, the identity provider. Well, now the identity provider comes to kick in. When we're actually getting the information from the stun and from the certificate store, what we do is actually using the identity provider to combine our identity with the fingerprint, so that they're now signed together. If you're changing your fingerprint, then the signature will not match anymore. Your assertion will fail. And if you send that around, then an attacker, the only thing it can do is either replace the whole SDP with a new signature with another identity, or only change the fingerprint while the signature will not match anymore. So in the case, he's actually only changing the fingerprint. It's going to the browser. And all of a sudden, the identity provider will say the signature doesn't match anymore, it will not connect. I have another.
If I have a third-party JavaScript which uses a malicious identity provider to set up an SDP session to the attacker, does that work?
Yes and no, depending on what the identity provider does as control mechanisms to check what it needs to sign. So you're sending along from your browser to the identity provider certain things to sign. Depending on what it actually visualizes to the end user while doing the signature, the assertion creation, it can actually get that information and show it to the user. If it just signs everything that comes in, your attack is potentially feasible. And that's actually something we're working on within our labs.
Yeah, also the way that you verify this is up to your application. So only the only thing that is provided to you is the assurance, okay, this blob of data was signed correctly. And then it's up to you to either see, is this identity on my whitelist, is the identity actually the one that I want to connect to? If you fail to do this, then again, this is worthless.
Okay. So to come back to the question in the beginning, how does the IDP actually is related to who is actually running the IDP? I would actually like to show you a few scenarios why I think IDPs can move to. Because this is, again, something that is very open in the specs. At this moment, I think only in the latest version of Mozilla, they are pushing in the identity provider already in there, so we were able to test that. I think in Chrome it's not implemented yet. So first, it's a little bit looking into the future. But if I look into the future, what are the scenarios that I think are plausible for identity providers? I'll quickly show you them. It's up to you to pick which one will actually be the most successful in the near future. So I think one of the scenarios that will be quite successful is the fact that the person or the identity running the signaling server will also running the identity provider. So you think you have any social network, you're actually having video conferencing capabilities on there. Actually, the network is actually running both the video conferencing as well as the identity provider. So this is the same stakeholder actually managing both. A second scenario could be that the user is able to choose on any site which identity provider he wants to use. So imagine that you're working in a browser, you want to connect, it gives you a pop-up, a drop-down list, which are the identity providers you want to use, which identity is already pre-configured, for instance, in your browser, is it okay to use this identity? We go even go one step further, and this is just a future envisioning, so it's not written down in any case, but you could also think of browsers being very correlated with the identity provider. You're a Mozilla user, by default you're using your persona which you already log into your browser to do the IDP. On the Chrome side, for instance, you're using your Google login to use for assertions. So this is a complete different scenario than the previous one. In the previous one, the end user really has a choice between identities. In the third one, you really say the browser will take care for you. That's also a possibility. And the fourth one is if you're actually having multiple signaling servers, it's a variation of the first one. Each signaling server has its own IDP. And this is also the scenario that Martin was describing in the beginning, where you have a federated setup. And with this identity providers, I think we're coming to the end of what we wanted to discuss today about security and privacy. So we can actually continue to the wrap up. And there's already a few questions popping up right now. Oh.
So, okay, what are our take-home messages? So the first one, again, the most obvious one, WebRTC, or the introduction of WebRTC, made our browsers more powerful again. And therefore, we have again an increased attack surface and also an increased toolkit for malicious parties to play with. And so, both for all the future technologies that you are developing, especially if you're developing or using WebRTC in any fashion, you should keep in mind what might be possible now with the increased attack surface.
Also, I think the hand-waving quiz also showed the permission model is very, very liberal. I think it's good to actually push the technology forward, that we don't hamper too much on the user. On the other hand, you also need to be aware that actually your browser suddenly become a peer-to-peer tool without actually needing user consent. Even if your company, your website is not using WebRTC, all of a sudden, now your web browser can be reached by any other party on the internet that is able to execute JavaScript in your browser. And this was something that was not able to happen before. A lot of people also thought if they were surfing behind the net, at least nobody could directly connect to their browser. Now all of a sudden, this is possible.
Then, as we said, WebRTC is designed to be highly flexible. Therefore, we do pretty much everything in JavaScript. And with great power comes great responsibility to do the right thing. So every single JavaScript that is running into your application has full control of all aspects of the WebRTC connection. Therefore, as soon as you have JavaScript that you don't trust fully, all built-in security guarantees that you might have with WebRTC, identity providers or DTLS connection security, everything is out of the window. Therefore, this is something that we reiterate at OWASP conferences anyway all the time. Use secure coding practices to get rid of unsecure JavaScript that might come through cross-site scripting, and also if you use third-party JavaScript code, probably shouldn't, or if you do, then do only very one that you trust a lot.
And last part is we already showed you that DTLS SRTP, although it's actually providing security guarantees, does not authenticate the endpoint. So really, if you're using WebRTC in the future, once it's implemented in all browsers, please use the identity provider, because it really is the last bit you need to set up secure end-to-end connection. And I would even state a little bit further, if you're actually using the best practices that Martin is describing on the client side, on your server side, you're trusting your signaling server, you're using your IDP, you're actually on a very good state in using the technology. And this is also something that we actually identified while doing the assessment. This whole WebRTC is a bit of a lot of technologies together, but it's really well thought in security-wise. Actually, security has been built in really from the start in actually developing this technology. So this brings us actually really to the last bit of our presentation.
Something else that we learned is that WebRTC is actually pretty cool, and it was a lot of fun playing with this. And so I encourage you to do this, and after also we told you now how to do this correctly. So, and also I have to echo Lieben's assessment. So it's very interesting that the specification process, the security was the main driver, and I think the most of the security problems that we have here come from the significant potential complexity of the setup that you might have. So simple WebRTC setups can be realized sufficiently secure. At least this is my gut feeling. As soon as you try to do something fancy, we will see.
So we also have some relevant sources to share with you. We don't have the time to discuss it all. Actually, it's a report of all the work we did in much more detail in the security project Struce to actually document on WebRTC, and also the upcoming WebRTC security challenges all bundled in a special issue that we edited at IEEE Computing, Internet Computing. And with this, actually, we are open for the last questions for this talk. Thank you. So the question was, is there any way for a user to actually use a browser that can disable WebRTC, or is there any way to disable WebRTC? I would say yes, there are. You're using older versions of Internet Explorer, and by default it is disabled. I would say it comes out of the package with Chrome and Firefox, and maybe there are extensions, there are all flags that you can give with starting up those browsers to disable it. I'm not sure, but I think for now you actually need to take into account your end user will use WebRTC or will have WebRTC within his browser within the next year for sure. Also, I now may say Internet Explorer, but also they're catching up really well and actually getting that information in there as well. Actually, I think it's dynamic because you're doing the UDP hole punching. You're actually relying on the UDP port that you're getting from the endpoint. So on the network, really, the internet, it will be varying. But on the client side, it could be that fixed port, but I don't know. I don't think it's a fixed port. Well, you could search for instance, the communication that is being set up to the turn, and then also make sure that the hole punching doesn't work. But it's actually purely on the network level. I would not say it's not possible at the application layer.
There was something that wasn't clear to me. So you can choose at the user level which identity provider to use?
No, not at this moment. So what is actually the APIs? It's actually one JavaScript line at an identity provider in domain. We foresee that it might be possible that, for instance, if there's no identity provider set up or there's an identity provider set up, that the browser gives the user control. But at this moment, it's not specified. It's just a hypothesis that a user might have different identities and that the browser is helping him in actually pushing these identities coupled to this control. But at this,
so it's at the application level, not at the user level.
Yeah.
I found one of the first slides, the usability aspect, quite interesting because with so many possibilities for the browser to communicate with the outside world, the usability becomes a very critical thing. I mean, to make it easy, but still secure for the user. So it's definitely something worth to investigate and research.
I think so. Usability is a key point here. So also the permission model we presented, you always have to the balance between usability and permissions and security. Also the fact that the topologies can vary so much, it's really making it very hard for the end user to understand what's going on. If I'm saying we'll have a mesh, I would not like to know what kind of consents I have to answer. So in that sense, I understand that a lot of things were done to actually be very user convenient. But as you saw in a more technical audience, security audience, sometimes it might be a shortcut. So I don't have the solution here. We just wanted to point out, be aware that those things are available within your browser. Yes, so the protocols are defined. It means it's the whole setup with loading an iframe from a certain origin and then two post-message ports, that's defined. So you're using web message, but it's very open. You only say, these are the interfaces, these are the messages that we will send and receive. But how the identity provider is implemented is fully up to the identity provider. And it's first a little bit hard because we don't have implementations yet to see how identity providers will actually propose this. So it could be, but my team student was actually trying this out. It will be kind of a hack to actually make it out because what you receive from the identity provider needs to be in a certain format, and that's specified in the spec. But you could use OAuth on top of that to actually make such an assertion, then some conversion. But it's not out of the box OAuth compatible, I think. So I think timing-wise, we will cut it down here. We are still available here at the conference. Thank you for the attention.